equals to integral 0 to pi by 4 sine 2x upon 1 plus cos squared 2x. 1 minus sine squared is cos squared. Now you know derivative of cos is sine more or less with plus or minus. So I'll put cos 2x equals to t. Substitution, remember. Now differentiate this. So this is minus sine 2x by chain rule into 2 dx equals to dt. You need only this much. So sine 2x dx equals to, this is there, equals to minus half dt. Now we change the limits. If lower limit is here 0, x is 0, place here cos 0 is 1, so t is 1. If x is here pi by 4, so I am putting pi by 4 here. So t becomes cos pi by 2. What's cos pi by 2? It is 0. So therefore, the integral would be here I equals to, instead of 0 to pi by 4, 1 to 0. This much is minus 1 by 2 dt. And this is t, so 1 plus t square. Minus 1 by 2 as it is. You know this is a standard form, tan inverse t. Limits are from where to where? 1 to 0. Minus 1 by 2 as it is. Tan inverse 0, which is 0, minus tan inverse 1, which is pi by 4. So required integral is just pi by 8. Now we go to next question number. Here 27. I equals to integral 0 to pi by 2 cos square x upon cos square x plus 4 times sine square x. Let's see this. So here one way is I'll just reduce everything in form of cos square. So this cos square as it is plus 4 times, instead of sine square, 1 minus cos square x dx. Integral 0 to pi by 2, this cos square, plus 4 as it is, here minus 4 plus 1, so minus 3 cos square x dx. I've reduced just in cosine function using that identity, sine square x equals to 1 minus cos square x. Now I'll set this expression over there. I did minus 3, so multiplying and dividing by minus 3. So 0 to pi by 2 minus 3 cos square x upon 4 minus 3 cos square x. I need plus 4, so I'll write plus 4 and minus 4. Now we'll do individual division. So 0 to pi by 2, this upon this just gives us 1. Minus plus 4 by 3. Integral 0 to pi by 2, 1 upon 4 minus 3 cos square x dx. So here you are through. Minus 1 by 3. What's integral of 1? That is x. 0 to pi by 2. Plus 4 by 3. This is very standard integral. You can divide numerator and denominator by, for example, let's write say sine square. Why? You will realize because 1 upon sine square become here, you know, cos x square. Here 4 by sine square, which is cos x square, and this become cot square. These also can reduce in form of cot. or you can divide by cos square also. So 1 upon cos square sec square, here 4 by cos square, which is sec square, minus 3. What I did, dividing numerator and denominator by cos square. You can divide by sine square also, remember. Okay. So this minus 1 by 3, upper limit minus lower limit. So this is just pi by 2 minus 0, plus 4 by 3 as it is. Denominator I'll just convert into 10. So this is 1 plus 10 square. So if I write one more step here, this is 4. If I open the bracket, 4 minus 3, that is just 1, plus 4 10 square x dx. Now you can just put here 10x equals to t. So this will be dt, and you can integrate it further. Question number 28, which is an important example here. 28 and 30 are more or less similar. I'll do 28 first. Pi by 6 to pi by 3. Inside the integral you have sin x plus cos x upon root sin 2x. Now we know that from sin x cos x you can get sin 2x. So what I'll do, I'll take integral of these as t. Why integral of these as t? Because after differentiation you must get this. So what's the integral of sine, which is minus cos, and integral of cos is sine. I'm taking these as t. Why I'm taking these as t? Because if I differentiate this now, what's the derivative of cos? You know, minus sine. So this gives you plus sine. What's the derivative of sine? That is minus cos x. Sorry, just cos x. Dx equals to dt. So you see this become dt. Fine. How I have chosen the substitution? Put this integral equals to t. What's the integral of sine? Minus cos. And what's the integral of cos? You know, sine. Integral of this equals to t. So once I differentiate, I'll get this. Okay. So I'm not going to change the limits. I'll keep as an indefinite integral. So this becomes dt here. Now how do we get the sin 2x? So the standard way is you square this. I'm squaring this. If I square this, cos square plus sin square gives us 1. What's the middle term? 2 sin x cos x equals to t square. Squaring on both the sides. Just squaring. This plus this the whole square. So cos square plus sin square 1, middle term is this. This is sin 2x, you know. And I'll interchange the terms. So 1 minus t square equals to sin 2x. So here I'm getting root 1 minus t square. Now what is this? You know that this is just sine inverse t. That's very standard integral. And therefore I equals to integral from you have pi by 6 to pi by 3. So sine inverse, what was t? That was minus cos x plus sin x. And now limits are from pi by 6 to pi by 3. Now you just write upper limit minus, instead of x you write pi by 3 and simplify. So you will get the final answer. 29th is a very basic question, just to take the conjugate. I will not do 29th. 0 to 1. You have 1 upon root of 1 plus x minus root x dx. So what you will do is here just to take the conjugate. 0 to 1. Conjugate of this is root of 1 plus x plus root x upon, here both will be free from the square root. Multiplying and dividing here with this expression, remember we are using conjugate concept. plus root x upon here root of 1 plus x plus root x. So these expression are copied here, a minus b, a plus b. So this both will be free from the square root. So this is just 1. And this can be integrated very easily because this is linear function. So how will integrate this? Just raise the power by 1. 1 plus x raised to 3 by 2 upon 3 by 2 plus x raised to 3 by 2 upon 3 by 2. And limits are from where to where? 0 to 1. So now you can do it. 30th question. As I told you, that is also an important, and it's like question number 28 here. So I equals to 0 to pi by 4 sin x plus cos x. When you have sin and cos both and the denominator is with sin 2x, we always put the substitution as I explained. What will be my substitution here? Integral of the numerator expression equals to t. What's integral of sine? Minus cos. What's integral of cos? Sine equals to t. Differentiate this. Derivative of cos, you know here minus sine. So this become plus sine. This is cos x into dx equals to dt. So this much become dt. Now you need to get the value of sine 2x. So how do we get this? Just squaring this. So cos square plus sine square 1. Middle term is 2 sin x cos x, as I did in question number 28, equals to t square. I need sine 2x only. This is sine 2x. So I'll interchange these two. 1 minus t square equals to sine 2x. I place both the values there. So indefinite integral, I'm not putting right now limit. This is just dt because this become dt. 9 plus 16 into 1 minus t square. Okay. So here this is 1 upon, if I open the bracket, 16 plus 9, 25 minus 16t square, which I'll write 4t the whole square dt. Now this is which formula? A squared, because this you can write 5 square. So a square minus x square with coefficient of t is 4. So 1 upon 2a, that is 1 upon 2 into 5, log of mod of, if you remember, 4t plus 5 upon 4t minus 5 upon the coefficient of t, that is 4. So I'll write upon 4. This is indefinite integral, remember. And this is equals to, this is nothing but here 1 by 40 log of, what was t? T was, cos minus cos plus sine. So it is sine x minus cos x plus 5 upon 4 times sin x minus cos x minus 5. And therefore here finally I means limits from this to this. So 1 upon 40 as it is. Here log of mod of 4 times sin x minus cos x plus 5 upon 4 times sin x minus cos x minus 5, and limits are from where to where? 0 to pi by 4. So just write upper limit minus lower limit and simplify. So you will get answer. I'm not doing further. I'm sure you can do it.